हाँ, सूर्य की स्क्रीन विजिबल है?
Yes, sir. Good afternoon, sir.
हेलो।
Yes, sir. Sir, आवाज नहीं आ रही क्या sir?
हाँ, ठीक। So, okay, so in previous class we were discussing about this satellite corrections, sorry, satellite clock correction, and today we will discuss this slide once again when we go back to the point positioning. But for the time being, just understand this as a core concept that satellite provides the correction in its clock directly to the user via navigation message. Why? Because at satellite end we have a atomic clock, and its receiver end we have a quartz clock. So quartz clock is generally of low standard and have a very large offset with respect to GPS time compared to the clock offset of the satellite clock with respect to the GPS time. So the drift or the correction of that satellite clock would be provided by GPS satellite itself with the help of this navigation file. So the other formats that are equally important are meteorological file, which is called MET format. So whenever you establish a GPS receiver at any location or any part of the globe, and you collect the data for, let's say, 1 day, so there will be a Rhinix file that will be available to you, but it will have 3 sub files. In one single folder, you have 3 sub files. That other file is called as observation file, another file is called as navigation file, and the third file is called as MET file. They have their extension as .o.n.m. Okay, so these are called as meteorological file. .m file is called as meteorological file, that is about the atmosphere related parameters that are provided. Okay, then other is orbits. So orbits, there are two types of information about the ephemeris or the orbit file of the GPS satellites. One is broadcasted to you, that is called as broadcast ephemeris, and another is called as precise ephemeris, that is prepared by certain agency after few days. So let's say you have collected data today. So there will be a broadcasted file of ephemeris, which we call as also as navigation file, that will be transmitted by the satellite with the help of the carrier, that is modulo to addition with the CA code and P code, which we are discussing just previous to this. That is called as navigation file. So that is navigation file is also called as broadcast ephemeris file. Just like the word broadcast refers that you are simply switching on the TV and you are getting the live broadcast of the cricket match. Okay, so there are the live broadcast ephemeris, as well as some are the precise ephemeris. So the precise ephemeris is not directly broadcasted. Instead, it is by some, with the help of some agency, it is uploaded on certain portal. Okay, so you will be accessing that portal for downloading that data of the satellite orbits. But in that satellite orbit, what is the problem is that it is the format is called as sp3 format. So now you could recall in your chemistry days, you will have orbital configuration of a particular compound, and you name it as sp3d, sp3, kind of thing. So that with the similar concept, this sp3 format has coming here, that the example which we try to explain here is the sp3 format contains directly the xyz of the satellites in ECF format. Now please remember, the ECF format is the earth center earth fixed format, in which the frame or reference system, the earth center earth fixed, is the same where you are calculating your own position. Okay, but in the broadcast ephemeris, it is not directly provided as the coordinate. Instead, they are the parameters with the help of which you are computing the satellite coordinate. But in the sp3, they are giving you xyz. So that's the difference between the two file formats. One is the broadcast ephemeris, where you are getting parameters, and in one of the laboratory, you will see that with the help of those parameters, you would be computing your xyz. But in the case of sp3, let's say if you can wait for 1 day or 2 day, you can directly get the xyz or precise xyz from precise ephemeris, which is in this format called sp3 format. where you have XYZ of the satellite coordinates in ECEF, directly in the ECEF. So you do not need any kind of transformation conversion like that. So that is the basic difference. You may read more about that precise ephemerides in the lecture book also. And there is a clock information. So clock data files are also available by the satellites to the end user. Anyways, then these formats are also properly used, like SINEX format, which we call it a software independent exchange format, to help researcher exchange their results. I mean, just like the communities, they are transferring this between themselves, the scientific community. INOX format, which is for ionospheric corrections or ionospheric information, that is being provided by the INOX format. The most important format is the Hatanaka format, which is called just like a WinRAR file. So these are the Hatanaka format is a compressed RINEX format where you have all three files in a compressed manner, which is available to end user. Okay, so coming back to your GPS services, which I have already provided the basic idea of the SPS and PPS. Two types of services are there. One is called as SPS, another is called as PPS. So SPS is positioning accuracy that is provided by GPS measurements based on single L1 frequency called CA code. The PPS, which is precise positioning service, which is the highest level of dynamic positioning accuracy that is provided by GPS measurements based on the dual frequency P code. So that's a two kind of services which are available. You can see it again. So most popularly, you always recall that there are two types of services. One is SPS and another is PPS. So SPS stands for Standard Positioning Service, and the PPS stands for Precise Positioning Service. So one in SPS, people are using the CA code on L1, and the PPS people are using the dual frequency P code. Now that's the agency which is responsible for providing variety of the data products is called as International GNSS Service, or in short we call it IGS. And you may recall that I've explained you that many times that there are several IGS stations worldwide around the globe that act as a monitoring stations for the GPS satellite system, or for time being they are also called as for the GNSS monitoring system. So the two international efforts which are very popular, one is called as IGS, which is International GNSS Service. Formerly, it was called as the International GPS Service, is a voluntary federation of more than 200 worldwide agencies that pool resources and permanent GPS and GLONASS station data to generate precise GPS and GLONASS products, and can be considered as the highest precision international civilian GPS community. So although it is a community, but it helps us in getting the, or in providing the variety kind of the products of the data for GPS as well as GLONASS. Responsible for providing the highest quality data and products. When I say products, that means, see, as I've explained you in the previous class, that there are two ways you can get the solution. One is you have a single receiver, you get data from a single receiver, and there is another positioning which we call as a relative positioning, where you have two receivers in place. One is base, another is rover, and you are simultaneously collecting the data. For code-based correction, you use word DGPS. For phase-based positioning, you use word relative positioning. Okay, so in these two cases, you whether it is a DGPS or relative positioning, you are applying correction from base to rover. But what if you have a only single receiver? Now you need to apply the corrections for variety type of error sources, let's say atmospheric errors, clock error, etc. What you need to do? You need to then you go for IGS products, and then you use those product files to apply correction in your single receiver file, so that the correction element for which you are dependent on something else, third party, that will be provided. So that is the difference between static positioning or single point positioning versus the relative positioning, where you have multiple receivers. So you have base, you have rover, and then you can work on it in the relative manner. So that is the difference, the basic difference, fundamental difference between two positioning. Here also, when you use a single receiver, you need products. Where you will go for the products? You will go to IGS. Okay, so responsible for providing the highest quality data and product as a standard for global positioning, global navigation satellite system in support of Earth system, Earth science research, just like we people are doing, multidisciplinary application and education. So at present, the IGS include two: GNSS, GPS, and the Russian GLONASS, and intends to incorporate more future GNSS, which include nothing but your Galileo, QZSS, and some other world-based navigation satellite systems. Let's say if you want to just go to this site, let me just open it up for you. It's very nice. Uh, Details are mentioned. Just wait a minute. So I'm just sharing another scene for, or let's say I should say the. So this is the IGS website. You should visit this website. Try to understand. So here it is. You could see this is here in a. Is it available, Sumit? You can see it.
Yes, sir.
So this is a GPS receiver, very conventional type of station placing. Tripod, over that you have a GPS receiver. Maybe this looks as a NetR9, but this could be anyone. Anyways, so this is a station which is placed over a particular bedrock, and in that website you could go to at the products, network, and news and announcement. So if you want to see the products, so it is a high quality products from Genesis data. It is the global network of 500 plus GPS. So when you go at the so-called products, so on products page you could see, you see such kind of products. So one by one you could read it. So it is precise orbit. So IGS collects, archive, and distributes GPS observation dataset of sufficient accuracy to satisfy the objectives of a wide range of application. And these data sets are used by IGS to generate the data products which are made available to the interested user. Another is precise orbit. As I've told you now, that there are two types of orbits. One is broadcast orbits, and there is another is precise orbit. So you see, so I'm just reading one line which summarize this precise orbit, is that uh, IGS analysis centers provide satellite orbit solution to CDDIs. This is a one archive center for hosting the data using predetermined schedule, that is sub daily, daily, or weekly, depending upon the product. The IGS analysis center coordinator retrieves these solution and produces a combined product, which is in then turn archived at the CDDIS. So CDDIS is a library where you can get this data. These combination solutions are considered the official IGS products The IGS orbit combination solutions are available in three formats. One is ultra rapid format, and final. Just like you could see some registration, early bird registration, or on the desk registration kind of thing. So similar in that you have a data set which is ultra rapid or final kind of thing. So ultra rapid product useful for real time and near real time application at regular intervals 4 times per day. The ultra rapid solution includes both observed and predicted satellite orbits. The rapid orbit combination is a daily solution available approximately 17 hours after the end of the previous UTC day. The final and most consistent and highest quality IGS product, which I was talking as the precise orbit, is generated on a weekly basis, approximately 13 days after the end of the solution week. So these files, ultra rapid, and precise, they have their certain accuracy standard, but these are frequently used for variety kind of applications. So when I say archive, you can go to get the archive solution for GLONASS only, as well as the GPS only, where the data file is stored in a compressed manner, where the GPS week is written, the analysis center name is written, then the day of the week is written, the type of hour, that is for ultra rapid kind of thing, and then the type of solution which is there, and you can have the compressed file. Okay, so similar to this, you have Earth orientation parameter solution, satellite orbit solution, orbit solution analysis summary, GNSS rapid combined Earth rotation parameter, GNSS rapid combined orbit solution, orbital solution summary product, like that. So these files now you must have questions, sir. How when we are using these files? So when you are working on a very classified kind of very specific project, which require highest possible accuracy or highest possible precision, then you use this kind of products. These are the clock products which I was mentioning in the one of the slide, that the clock products are also need to mention. So these clock products are the rapid, again the daily, weekly, as well as the in their different form, the rapid form and the final form. So these are available. Then again, the Earth orientation parameter, which is the reference frame. For that, you have the solutions which is available in the Sinex format. Then you have ionosphere format. Then you have tropospheric correction. Then you have DCB, which is differential clock bias. They are called as the systematic error or biases between two geniuses code observation at the same time or different frequency. And then this real-time comparison. So these are the IGS data. You will be getting more information about the use of these data whenever you use so-called particular application. Like, what are the type of applications? When we do the monitoring deformation of solid earth, when we monitoring earth rotation, when we are monitoring, these are application, a variation in the hydrosphere, scientific satellite orbit determination, monitoring the earth ionosphere and troposphere, time and frequency transfer. So these are the kind of application when we explore, we get this type of the so-called data set which we will be using. Okay, so let me just again unshare it. Okay, so member of the Federation of the Astronomical and Geophysical Data Analysis Services, and operates in close cooperation with the International Earth Rotation and Reference Services. The full form of now IERS is changed a little bit. That is called as International Earth Rotation and Reference Services. The primary objective of the IGS is to provide a service to support through GPS data products, geodetic and geophysical research activities. And the secondary objective is to support a range of activities performed by the users, such as those developing and maintaining national geodetic datums. Hence, just like those agencies who are maintaining national geodetic datums, like the vertical datum and horizontal datum for a particular country. In our country, it is Survey of India. So let's say if Survey of India needs the particular support from service to data products, they will be accessing this IGS website. Okay. Hence, the IGS also develops the necessary standard and specification, not too dissimilar to those developed for standard GPS. So high accuracy GPS satellite ephemerides a variety of post-processed orbits such as rapid, final orbits, as well as new predicted product orbit. Earth rotation parameters, coordinate and velocities of IGS tracking station, GPS satellite and tracking station clock information, ionospheric and the all kind of applications which we have seen. That is, the data is provided for that. So how many stations? So 440 station and 368 active station as on 27 December 2012. And if you want to see the real particular data, you can go and access the IGS sites for better details. You still can get the download the data because it is available in website in a different folder name called data. You can access that data. Okay, so that is one part, and you can also access the IGS stations available to a particular user. Okay, so we are skipping this. The IERS, which is also known as Indian Earth Rotation and Reference Services. Let me just also show you that it's very good. Okay, so I'm again sharing this IERS website for you people. Just look at this. It is saying International Earth Rotation and Reference System Services. I've told you. Now the name is changed. So you have analysis center, product center, techniques which are available. You can also access to the data, orientation data, ICRF, ICRS, ITRF, and ITRS. So let's say for timing, you just open the ITRF. So ITRF for ITRF is an International Terrestrial Reference Frame, is a set of points. So whenever you call about the frame, it is a set of points with a three-dimensional Cartesian coordinates, which realize an ideal reference system, the ITRS, as defined by IUGG resolution number so and so in Vienna. Contains Cartesian coordinate and velocities, Earth orientation parameters, site catalog, the identification number, the documentation number, and the previous realization. So at present, it is working in the ITRF 2008. The previous version is 19, 91, 92, 93, 94, 96, 97, 2000, 2005, 2008, and 2014. So these kind of uh, frames information is available. You can see it. So even you can read the document also if you want. So let's say if you want to see this document, you just click it and it will open up a PDF file where you can access the improvised solution that are available by the IERS agency. So it is basically it informs you about the rotation, Earth rotation, and the existing or a well-defined conventional reference systems as well as the frames. So that helps you in understanding the different types of Earth rotation and reference system service that helps us in identifying the pattern of changes in the reference frame. So established in 1987 by International Astronomical Union (IAU) and International Union of Geodesy and Geophysics, the IERS accomplishes its mission through the following component. One is called as technique centers, product centers, combination center, analysis coordinator, central bureau, directing board. So these are the different centers which help us in producing that data which we need. Okay. Now coming back to our original discussion, that's a little bit about the background where you will find the data. Now this is this particular slide which is just open in front of you. It's mentioned about the model for code pseudo ranges and carrier phases. So what we are right now reading is that's okay. That's now we know about the basic fundamental principle, like how GPS works, how the satellite signal is decoded, how the signal cross the sorry called autocorrelation phenomena occurs. What do you mean by signal, actual signal? What do you mean by replica of a signal? So these all different concepts is okay. But now how to model for code pseudo ranges, that is one issue that we need to understand. Given following definition, the TS, which is the terminology is I'll explain one by one. So let's say TS is the satellite clock time at signal emission. Okay, so now you just open up your imagination window again. Just think that your satellite is emitting the signal from its end, and it is marked as TS. Okay, that is offset from actual GPS time. Okay, TR is receiver clock time at signal reception, which is offset from the actual GPS time. Okay, now if it is actual offset is available, then how the offset is represented? They will be represented as delta S and delta R. So delta S is satellite clock delay with respect to GPS time, and delta R is receiver clock delay with respect to GPS time. Okay, now TS star and TR star is the satellite clock time at signal emission in GPS time frame, set receiver clock time at signal reception in GPS time frame. Now this looks little confusing since you are reading the first time. So very simple. Suppose you have a watch in your hand, both at the satellite end and as well as the receiver end. Just imagine that you have a watch in your hand, which we call it as a receiver clock, as a satellite clock. So now those who are having a satellite end, they will have a watch in your hand that will be called as a satellite clock. Okay, somebody will be having the at the receiver end a clock that will be called as a receiver clock. Now this both two clock have offset from the standard GPS time. Why? Because they are not they are having they are going through the several forces over acting over it, and they are going through the certain drift. So there is a variation from GPS standard time to these clocks. Okay, so let's say you are having a clock at the satellite end that is not showing the actual time in GPS time frame, but itself it is showing little offset from the GPS time, although it will be minimal because they are atomic clocks, but there would offset would be there. Similarly, to receiver end, they will be having offset from the GPS time, but it will be large. Why? Because they are, again, they are quartz clock. They have certain larger offset, and they are actually poor clocks. They are low substandard clocks, but because to maintain the cost of it, we have to manage it. Okay, the satellite and at the receiver end, we have to manage with the cost of the receiver. So at both end you have a clocks, but both have offset from the GPS time. This offset is measured as a delta S and delta R. This offset, let's say if you mark a line as a GPS time, so the offset of GPS satellite clock is delta S, and offset of receiver clock as delta R. Okay, that if that is the case, then what would be the actual time on GPS time frame? So that is written as TS star and TR star. Okay, so that means actual TR is nothing but the TS star plus delta S. TR star is equal to TR plus delta R. So when we take the difference is nothing but delta T is nothing but TR minus TS. Now the TR is located written as TR star plus delta R. TS is written as TS star plus delta star. So just observe these three fundamental equations that is presented on your screen. Just observe it. Any doubt in this? अब आप बताइए व्हाट वुड बी द नेक्स्ट स्टेप, क्योंकि ये मॉडल किसका है, मॉडल फॉर कोड स्यूडो रेंजेस। तो स्यूडो रेंज निकालने के लिए अपन लोग को क्या करना पड़ेगा, व्हाट वी नीड टू डू?
सर ये टाइम शिफ्ट को मल्टीप्लाई कर देंगे लाइट ऑफ स्पीड लाइट ऑफ।
बिल्कुल 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 बिल्कुल। So that is next step, but before that a little rearrangement of the delta term, so that delta r plus tr star minus ts star plus delta s, इनको रीअरेंज किया गया है, जिसमें से जो स्टार वाले टर्म है उनको एक साथ रखा गया, जो डिले वाले टर्म है उनको एक साथ रखा गया, दैट इज रीअरेंज। अगेन आप ऊपर देख लीजिए, टी आर को रिप्लेस किया गया है यहाँ पर, जो डेल्टा टी है टी आर माइनस टी एस, टी आर को रिप्लेस किया गया टी आर स्टार प्लस डेल्टा आर से, और टी एस को रिप्लेस किया गया टी एस स्टार प्लस डेल्टा एस से। और उनको रिप्लेस करने के बाद, थोड़ा सा रीअरेंज करने के बाद, नाउ वी आर मल्टीप्लाइंग इट विद द सी। तो लेफ्ट हैंड आप देखिए, सी से मल्टीप्लाई आप कर रहे हैं, सी डेल्टा टी इज इक्वल टू, इसमें भी सी मल्टीप्लाई होगा, सी टी आर माइनस टी एस, सो दैट वुड बिकम सी टी आर स्टार माइनस टी एस प्लस सी डेल्टा एस माइनस डेल्टा आर। So this actual star term is the actual GPS time, so that would become the geometric range, because if there is no error, there is no delay, then pseudo range would become equal to geometric range. But although it is not a possibility, sometimes because of the delay in the signal, this geometric range changes to pseudo range. So this pseudo range P is denoted as rho plus C delta R minus delta S. Then geometric range rho is also noted as pseudo range P minus C delta R minus delta. That means it will be shifted on the left hand side. So this geometric range rho would become P minus C delta R minus delta S. एक बार इसको देख लीजिए आप लोग। So I hope there is no problem. This geometric range is written as pseudo range minus this error term or delay term. Okay, let us understand this. So pseudo range or apparent satellite receiver distance obtained through, which is called as correlation of the modulated code and the received signal from the satellite with the replica generated in the receiver. Again, the pseudo range or apparent satellite receiver distance is obtained through correlation of the modulated code in the received signal from the satellite with the replica generated in the receiver. Okay, and it is affected by series of error or bias term which are added to the geometric distance which is listed here. So at satellite end, you see this is your at the time of emission, satellite is here. At the time of reception of the signal by the receiver, satellite shifted at this place, because satellite is moving at 4 kilometer per second kind of speed in the space. Just imagine 4 kilometer per second. Okay, so this satellite that has transmitted the signal, by the time it reaches the receiver, the satellite is moved by this much distance, and this the reception is received by this much. So at the 1 millionth of the second, the signal reaches at the so-called receiver end, because you have 300 meters. Just 300 meter would be 0.3 kilometer divided by 4 kilometer per second, so it would be around 0.075 seconds. So by the time satellite signal is received, satellite the delta t would be something around 0.075. That is within a one thousandth of the second you can compute this clock delay. So the error sources: satellite clock offset less than 300 kilometer, relativistic correction 13 meter, satellite instrumental delays around a meter, geometric distance actual is 20,000 kilometer, ionospheric delay 2 to 50 meter, tropospheric delay 2 to 10 meter, receiver clock offset again around 300 kilometer, and the receiver instrument delay that cost around something meter. So these are error terms are mentioned because of the various errors that are affecting the signal. Please remember, the highest possible contribution of the error is coming from the clock. That I've told you also, that if your this clock or the time of travel estimation is having error of 1 microsecond, just imagine 1 microsecond, the error in the length measurement or the range measurement would be of 300 kilometers. Sorry, 300 meters, because it is 1 microsecond. So 1 into 10 power minus 6 multiplied by 3 into 10 power 8. So that becomes 300 meters. So just imagine that 1 microsecond kind of error, if you commit, you would be somewhere in the 300 meter range, above of the surface of the earth or below surface of the earth. So the time measurement is very much important. That's what I'm trying to say it here. Just look at the slide. Is there any question? Is there any doubt? Any questions? Just feel free to ask if you have any kind of questions. Don't worry that at this time the questions cannot be at you can have any question whatever you want. If you have any even a silly doubt also, you can ask.
Sir, which
Huh.
distance we found out from that previous formula? Now we add all these biases that which is given.
No. That's what I'm saying. That's I said. Na? See, You are not adding these errors. They are part and parcel of that error sources. So they are already added. Just like
Okay.
this, understand this. You cannot measure anything perfectly. Just like as in the previous semester, I told you, no measurement is exact in nature, and there is no true value. True value is always unknown. So when true value is unknown, what will happen? Your observable contains the error. Similarly here, ideally the distance of the orbit from the earth is 20,183 kilometers is there. But sometimes you get 22,000, sometimes you get 24,000. So why it is happening? It is because your the hardware has certain kind of error sources, or your mechanism of the estimation of the so-called range has error sources that are part of your measurement. So when I say receiver clock error, tropospheric delay, atmospheric, ionospheric delay, satellite instrument delay, so they are all part of your pseudo range. That is P. Ideally, it should be rho, but rho is always added up with these all errors, which we call it as the error sources of the delay sources. Get it?
Yes, sir. Yes, sir.
Any more question you can ask freely. Do not worry about the okay, should I ask or not. Just simply, if you have any doubt, you can ask. Okay, if no question is there, we can move to understanding the code model. Light book, which is already there with you, you can go ahead, start reading that book. So first line, just everyone be focused one by one. The left hand side, first line, it is written as PIJL1CAT. That means pseudo range computed between ith receiver and jth satellite on the basis of CA code that is modulated on L1. That's how we read this term. Which term? This one term. This term. Again, pseudo range between ith receiver and jth satellite that is computed with the help of CA code that is modulated on L1 becomes the pseudo range is equal to geometric range plus the error term, which is the clock delay term, plus the ionospheric term, plus relativistic correction, plus tropospheric, plus the total, so-called multipath hardware delay, satellite receiver group delay, and everything, plus the noise, because every measurement will have a noise term. Just understand the first line. Ideally, there should be zero. They should be not present the upper three term like these term. These terms should be not present in this equation, but because of the error sources, they are there in this equation. Just observe it. Similar to the second equation, it is the pseudo range between ith receiver and jth satellite for the P code that is modulated on L1. All terms are written. The third line is the pseudo range between ith receiver and jth satellite for the P code modulated over L2. L2 is your carrier. L1, L2 are the carriers. So D IJL1CA, which is nothing but the total hardware delay and multipath effects, are written as receiver hardware delay plus multipath delay plus satellite hardware delay. So I hope this equation is very clear. The above figure, which we have explained, is simply represented in terms of equation. Coming back to another segment where, as I've told you, why we use dual frequency receiver to mitigate the effects of ionosphere. Why? Because ionospheric error is dependent on the frequency term. So ionosphere is inversely proportional to the square of the frequency. So PIJL1, which is called as the pseudo range between ith receiver and jth satellite for P code modulated on L1 is written as this one, above line. But the second one is replaced by the term called F1 square by F2 square multiplied by I1. Ideally, it is written as I2, or simply it is written as IL2, which is represented here as F1 square by F2 square multiplied by I1, because the frequency, it is inversely proportional to the square of the frequency term. Okay, just see it. So if you want to just open up the equations, you can open up it up in terms of multipath and combined receiver and satellite delays. What I suggest you that at least you should write that the bottom three equations in your notebook right now, so that you understand how to write it. Otherwise, what will happen that when you come back and you will go for your mid semester examination or end semester examination, probably you will not be able to write this equation because you have not practiced it enough. So it is better that you start write these equations for now time being in your notebook right now, and just write these three equations. I'm giving you 5-10 minutes that you just write these equation and feel it and ask to yourself, do you understand the individual term what I have told you, or you wanted to repeat it again? Just take your time, all of you, and send me one screenshot also in your chat box that you have written, everyone. Okay, I've received one from Alok. Others also, just send it on a snap on your chat box. Okay, so most of the people have sent it. So Veli Shetty, can you explain each equation that is shared on the screen? I'm just, I just think that you should one by one explain it also. The first equation, yeah.
Sir, the distance from ith receiver and jth satellite with a CA code on the L1 observation
Modulated on L1.
modulated on L1 gives us is equals to geometric range plus the pseudo range of this delay.
No. Is
Sir,
equal to the is equal to the geometric range plus.
geometric ranges plus
बोलिए next term. देखिए जो
That is
फर्स्ट टर्म है, the after is equal to sign, the first term is
pseudo
geometric range.
geometric
Okay,
ranges.
the left hand is the pseudo range. Please remember everyone, the left hand, that is capital P, is the pseudo range, which is actually measured by your receiver. Okay, what we are doing, we are just opening up the component of that individual pseudo range by indicating the different subcomponent. So on the right hand side we are mentioning those components. So first term is geometric range, next is
Next,
बोलिए हाँ
but ionospheric effects.
no, that's you missed this
Second
component error
error
due to
term multiplied with
satellite
velocity.
error due to satellite receiver clock synchronization, or error due to receiver satellite clock offset. Okay, because it is delta, it is the double term which is written as c delta, and then again we also name it for the time being as delta ij. Okay, so it is the error due to satellite and receiver clock offset. Okay,
Yes, sir.
and the next term,
Due to the ionospheric effects from ith receiver and jth satellite.
nahi, ionospheric you have to just say it as ionospheric
Ionospheric
error between ith receiver and jth satellite for the ca code modulated on L1.
modulated on
Okay,
L1.
very nice. And it is a time dependent, the within bracket time is written, it is a time dependent, for every epoch it will be changing. Okay,
Yes, sir.
and then
Next, this term I don't know. So that
it is relativistic
wait,
correction. Okay, next
next term is a tropospheric error due to from ith receiver and jth satellite.
okay, and
Next,
this
that
next
is a
one is
multipath effects from
multipath. What is multipath? Multipath is that instead of signal directly coming to receiver, it is reflected by nearby surfaces like
yes,
metallic surfaces or buildings or any other surface. If it is reflected from that place and then it again it is received to the receiver, then this process is called as multipath. Instead of coming from the single path, it is has taken multipath to reach to receiver.
receiver.
Okay, good.
Next,
Okay, so
kth
is
term
combined
combined
satellite and
satellite and
receiver.
receiver delays.
Okay, plus noise term,
Noise
because
occurred in this path.
yeah, or you can also call it as the
Error,
error term, journal error term, or simply
general
noise
error
term.
term in terms of receiving towards the receiver.
Yeah. Good. Okay. So everyone should read one by one like this. That would give you confidence. Okay. So see, up now you have on your notebook everything is written. Now you match one by one. Try to read it one by one. That is the objective. So now you have written it on your from your hands. Now you can feel it. That individual component. You should be aware of these individual components. Now, one by one, let us just see. So first is geometric vacuum distance. If everything is okay, there is no error, it should be the geometric distance, but ideally it is not the case. Second is ionospheric delay at L1, always positive for code, depends on ionospheric condition along the path and on frequency. The tropospheric delay always positive for code and phase and independent of the carrier frequency. This is a very fundamental difference, that tropospheric error would be same for L1 or L2. So there is no subscript for L1 mentioned in the for the tropospheric, because it is independent of the carrier frequency. However, the ionospheric is dependent on the carrier frequency, and it is always positive for the code and negative for the phase. We'll see that. The reason will be explained in the error sources. Receiver hardware delay, multipath, satellite hardware delay, and so on. Okay, the noise term also. Now let us write this equation. The first box equation on your note sheet once again. I'll explain the left hand side. It is the phi, which is the phase in terms of cycle. Phi phase in terms of cycle, it is written as phi between the phase in terms of cycle between ith receiver and jth satellite for L1 is equal to the so-called your geometric range plus the clock error term minus the ionospheric term, the tropospheric term, the relativistic error, the delay path, the ambiguity, plus the noises. You just write individually each component on your notebook once again. Take a time, write one by one. Phi ij L1t is equal to. Now on the right hand side, just observe that this is written in terms of meter. Okay, let's say rho ij is a meter term, and when you are representing something in cycle, it has to be unitless. In order to make it unitless, how would you do it unitless? You multiply it by f1 by c. So upper term is per second, bottom term is meter per second. So when you multiply it with something which is meter, the whole term becomes unitless. So that's how it has been done. Just do not worry, just simply assume that okay, this is a meter multiplied by f1 by c. Here it is the delta t's term is a second, it is in second, so it is meter per second divided by meter, so only becomes per second divided by second. So this is also unitless, this is also unitless. This is again in terms of meters, so it is multiplied by f1 by c and so on. Just observe it. If you are following the previous equations, then you will follow these equations also. Just write it down once again in your note sheet. Any doubt in any equation term? It looks large, it looks complex, but when you try to write one by one components, it's familiar. You are familiar with each and every component.
सर इसमें k भी यूज हुआ है इस बार. लास्ट टाइम I to J था, इस बार I to K भी है.
Where?
सर
Oh,
in D.
that is a typo. That is a typo. Please ignore that. If it is something somewhere it is K is written, that is a typo. Everything is written between I and J. Any questions? Okay, so if you have written it, now let us see the individual terms. Another way of writing the phase in length unit of meters. So you see, if you multiply the previous equation by lambda, you just simply multiply the previous equations by lambda, you will get the capital phi ijl1. Now the previous term was written as f1 by c. Okay, if you multiply the whole term as lambda, what will happen? F lambda by c, that is again c. So c by c cancel out. Then c by lambda, when you multiply it by lambda, that lambda would cancel out. So the whole objective is that you should multiply the first equation, the previous cycle equation, by lambda to multiply, and to get the number of cycle, if you multiply it by lambda, it will become meters. Okay, so that equation becomes capital phi ij L1t is equal to rho ijt plus c delta rho ijt minus ijl1 phi t plus tij, and same the other terms. So just focus on these equation. This is again for all of you. Let me just again explain that this is phase equation in terms of meters. The previous equation, this which you were observing, which looks little complex, is because it is written in terms of cycles. So in order to primarily write in terms of cycle, you have to explain the individual term and represent the individual term in terms of cycle. So that's why the previous equation looks little complex, but it's very easy. The second equation, the second form which we are observing right now is a phase expressed in length units, which is meters. Now, individually, if we want to see the different components, these are the components. You see, So these are the individual term. One is the geometric vacuum distance receiver, ij. Now those who are little again confusing, sir, why we are explaining two equations. So one is the code pseudo range equation, that is with the help of code which is modulated on carrier we are computing the range. Okay. And another is the phase term, because once you demodulate the code you have the carrier which your receiver reconstructed and try to measure what is the phase difference between the incoming signal and the signal generated inside the receiver. So you can use the carrier phase also as observable. So this second part of equation is part of the carrier phase observable which we are observing. Okay, so that's why these two equation is written, and plus the ambiguity term is always there because that is the part of the your so-called carrier phase observable, since the initial term number of carrier phase cycle which is unknown to us, the integer number of in carrier phase cycle which is unknown to us, that becomes the ambiguity which will resolve we are as we are considering them as an part of the unknown process. They consider as an additional unknown, so that we would compute it. So with this particular component ends here. I'm just uploading it. I don't know whether it is already there to your Sumit. Is it already available?
No, sir.
Just a minute. I'll just send it. There is some problem. It is not uploading from my end. Let me try it once. So I've just sent it to Sumit. He will share among all. It's not uploading here. No issues. So okay. So with this, we stop here, and we'll discuss math